Let's practice simplifying square roots together. In each of these practice problems, we're going to go ahead and simplify each of the radicals fully. Once we simplify, we're going to go ahead and check to see if our simplified version is the same thing as our original version on a calculator, and we're going to approximate these decimals to the nearest hundredths place just because they're going to go on forever, so we're just going to approximate. For number 1, we have the square root of 64. Now just keep in mind that if you don't know that there is an invisible little number that is right outside this radical, it's an invisible little 2, and that just lets us know that we're looking for 2 of the same number that equals 64. We do know that maybe the square root of 64 is equal to 8, but I just want to go ahead and show you a strategy that may help you with doing these for the not so nice ones. So let's go ahead and take the number 64 and let's break that down using prime factorization. So maybe you could do something like 8 times 8, so we actually know it's a perfect square from that. But I'm going to go just a step further just so we can see this whole strategy so it can apply to the other examples. So notice how we're just going ahead and making a prime factorization tree and breaking down 64 into its most prime factors, or just the prime factors, right? So notice how we have a 2 and a 2, another 2 and another 2, and another 2 and another 2, right? So once you have all the prime factors, if you go ahead and pair up any 2 of them, you get a perfect square. So let's say 2 and 2 together is going to make 4, so that's a perfect square. Another 2 and another 2 together make 4, that's another perfect square. Another 2 and another 2, that makes another perfect square. So turns out that you can combine the 4 times 4 times 4. If you multiply a perfect square by a perfect square, you always get another perfect square. So basically we know 4 times 4 times 4 is going to equal 64. So that means you can break down the square root of 64, right? If we go ahead and say the square root of 64, that's going to be equal to the square root of 4 times the square root of 4 times the square root of 4. So the square root of 4 is going to equal 2, the square root of 4 is another 2, the square root of 4 is another 2, so 2 times 2 times 2 is equal to 8. So when we look at the square root of 64, it's what number multiplies by itself to get 64, and that's going to be 8 because 2 8s together multiplied get you 64. Now while writing all of this out wasn't necessary maybe for this example, hopefully it helps us for some other ones where we don't have perfect squares. Alright, let's check out number 2. For number 2, we have the square root of 50. So let's go ahead and rewrite this. We have the square root of 50, right? And we know it's a square root because if you don't see a number, there's an invisible little 2 here. We're going to see what this is equal to. Okay, now we're just going to go ahead and take this 50 and break it down. Let's go ahead and multiply maybe 5 times 10. That would be 50, and then 10 breaks into 2 times 5. Okay, so we have our prime numbers now. We have 5, and then we have a 2, and then we have a 5. All right, so now do we see any matching numbers? Well, I see 2 5s multiplied together. 2 5s is going to get us 25. So we have a 25 here. And then what else do we have? We just have an extra 2. So there are no other numbers. So we're going to say, well, 25 times 2, that does equal the 50 that we started with, right? So we know the square root of 50, which is what we're actually talking about, is equal to the square root of 2 times the square root of 25. So the square root of 25 is equal to 5, and the square root of 2, that's not a perfect square, so that just has to stay inside. That's equal to the square root of 50. Okay, so that's what we can write for our most simplified radical. So we're going to go ahead and write 5 root 2, right? Remember, the definition for most simplified radical is that there are no perfect square factors on the inside of the radical, so that 2 has none of that. Moving on to number 3, we have the square root of 72. Let's go ahead and write that, the square root of 72. Again, this one's not going to be a perfect square, but I think there might be some perfect squares hidden inside of it. So let's take 72 and let's go ahead and break it down. 72, we can say maybe 9 times 8, and then 9 is going to break into 3 times 3, and then 8 can break into 2 times 4, and this 4 is going to break into 2 times 2. Now this 3 is prime, this 3 is prime, we have a 2 that's prime, a 2 that's prime, and another 2 that's prime. Now let's just look for some pairs. Looks like 3 and 3 are going to make 9. That's going to be a perfect square. Looks like this 2 and 2 together are going to make 4. That's a perfect square. And this 2 that's left over, that's not a perfect square, but 9 times 2 times 4 is equal to 72. All right, we just kind of rearranged some of the factors here. So the square root of 72 is equal to the square root of 2 times the square root of 4 times the square root of 9. And so what is the square root of 9? That's 3. Square root of 4 is equal to 2, and then we still have this root 2. That's equal to root 72. And then on the outside here, we can multiply 3 times 2. That's going to equal 6. So we can say 6 times the square root of 2, or 6 root 2, equals the square root of 72. So we can go ahead and write that. It's going to be 6 times the square root of 2. That would be the most simplified version for the square root of 72. Now, before we go further, let's just go ahead and double check each of these. Now, for the number 1, if you just want to plug that into a calculator, you can see here that the square root of 64, that's just equal to 8, right? Go ahead and plug that into a calculator, see if you get that. And if you try to check both versions of this, well, 8 is equal to 8. So I think that's going to check out, so we don't have to worry too much about that. Now, if we want to check out, number 2, why don't you take a moment and plug in the square root of 50 into a calculator. I'm going to go ahead and do the same thing, just because I don't know the decimal approximation, and we're going to the nearest hundredths place, right? So the square root of 50, if I go ahead and plug that into my calculator, again, we should probably use an approximation symbol here because we are approximating. We're going to the hundredths place, right? So that's going to be 7.07. All right, so go ahead and try that on a calculator. And then you should also go ahead and type in 5 times the square root of 2. I'm going to go ahead and do the same thing here. And I'm also getting exactly the same decimal value of about 7.07. So if you want to check to see that these are correct, then you should go ahead and do so to make sure that everything is working the way it's supposed to. All right, if you look at number 3, if you take this square root of 72 and you throw that into a calculator, let's go ahead and do that. 72, take the square root, I'm getting about 8.49, right? If we round to the nearest thousands place, and then take 6 times root 2 or 6 root 2, do the same thing. I'm gonna type that in on my calculator. If you need to pause and try it on your own, make sure you're also getting 8.49, which I'm also getting. So I know that these are indeed the same thing. And now inside the radical, we have no perfect squares hidden inside of here, and so that we know it's fully simplified. For number 4, let's see, we have the square root of 48. Let's go ahead and set that up. So we have root 48. Let's put a little 2 on here. So we're looking for what number times itself. So 2 factors to get that 48 that have to match. And so let's see, 48 can break down into 6 times 8, that's 48. 6 will break into 3 times 2. 8 can break into 2 times 4. And 4 will break into 2 times 2. So here are all our prime factors. We have a 3, a 2, a 2, a 2, and a 2. Remember, every 2 matching numbers, right, are going to tell us a perfect square. So a 2 and a 2 is going to make 4. Another 2 and a 2 are going to make another 4. And then we have this leftover 3, so that's going to be not a perfect square. But 4 times 4 times 3 will equal 48. Which means if you had the square root of 48, that's equal to the square root of 3 times the square root of 4 times the square root of 4. The square root of 4 is 2, the square root of 4 is 2, the square root of 3 is still a square root of 3. That's equal to root 48. And then if you multiply this 2 times 2 together on the outside, that's going to be 4. So that's going to be 4 root 3, or 4 times the square root of 3, equals the square root of 48. Right? So we can go ahead and say that the square root of 48 is the same thing as 4 times the square root of 3. Plugging this into a calculator, if we just take the square root of 48, go ahead and type it into a calculator and pause if you want to go ahead and see what you get. I'm going and getting about 6.93, okay? And then I'm going to go ahead and type in 4 times the square root of 3 and see what I get. Go ahead and do that on your own as well. And I'm also getting 6.93, right? So I know that these two are equivalent to each other or are equal to each other. For number 5, we have the square root of 108. So let's go ahead and write that. We have 108, and we're taking the square root of it. Okay, let's see what that is equal to. Let's take 108. Let's see if we can find any perfect square factors inside of this. Now, it's up to you what kind of factors you use here. I think 2 times 54 is pretty easy for me at least. Feel free to use different numbers. And then I'm going to use 6 times 9 is 54. 6 is 3 times 2. And 9 is 3 times 3. Okay, so let's see here. We have a 2, we have a 3, we have another 3, another 3, and another 2. So again, every 2 will get us a perfect square. So 2 and 2 match, that makes 4, that's a perfect square. 3 and 3 match, that makes 9, that's a perfect square. And then we have a leftover 3 here. All these 3 together equals 108 if we multiply. So that means the square root of 108 is the same thing as the square root of 3 times the square root of 9 times the square root of 4. Square root of 4 is 2, square root of 9 is 3, times the square root of 3. That's going to be equal to the square root of 108. And then multiplying this 2 times 3 together, that's going to be 6. So 6 times the square root of 3, or 6 root 3, is the same thing as the square root of 108. So our most simplified version here is going to be 6 times the square root of 3, or 6 root 3. Going ahead and checking this, let's see, what's the square root of 108? It's definitely not a perfect square, so we take this 108, and then we go ahead and take the square root. I'm getting about 10.39, rounded to the nearest hundredths place. And then if we go ahead and take the 6 times that square root of 3, or 6 root 3, type that into the calculator, that is also about 10.39. So you can see that both methods, or both versions of the same thing, should equal the same approximation. Alrighty, number 6, let's see, we have the square root of a bigger number here, so let's try finding out the square root of 468. Okay, let's put a little 2 out here just to show that that's what's happening. We're looking for 2 of the same thing. Let's go ahead and take this 468 and see what can we break it down by. It's a pretty big number here, right? So it's even, so I'm gonna start with that. So if I take 468 and then divide by 2, that should be 234, okay? It's still an even number, so I'm thinking maybe we can divide by 2 again. I'm gonna put a 2 over here, and then half of that I think is gonna be 117, okay? 117, and if you're wondering what this is divisible by, well, 1 plus 1 plus 7 is 9, so we should be able to divide this by 9, and that means we're gonna get 13 times 9, I believe, and then 9 breaks into 3 times 3. All right, so we have some prime numbers here. We have 2 and 2, we have 13, and then we have 3 and 3. So every 2 of the same thing gets a perfect square, so 2 and 2 make 4. Okay, that's a perfect square. 3 and 3 make 9, that's another perfect square. And then we have this 13. So 4 times 9 times 13 equals 468. But then if you're wondering what the square root of 468 is, it's the same thing as the square root of 13 times the square root of 9 times the square root of 4. Square root of 4 is 2, square root of 9 is 3, square root of 13 is an irrational number, so let's just keep it the same. And then this is going to equal what? The square root of 468. This 2 and 3 multiplied together gets you 6, so this is going to be 6 root 13 equals the square root of 468. So we know that that is the most simplified version here. So it's going to be 6 times the square root of 13. Now just checking this, if we take the square root of 468, again, feel free to pause to go ahead and try this out. So I'm going to take my 468 on a calculator and take the square root of it. I'm getting about 21.63. Okay, and then go ahead and take that 6 root 13, also plug that into a calculator, pause and give it a go. And hopefully we also get 21.63, which I'm also getting 21.63. So this does check out. For number 7, we have the square root of this 245. Let's go ahead and see if we can find the square root of this thing. So again, let's go ahead and see if we can break down 245. It's helpful to know what the factors are. So it ends in 5, so I know I can divide this by 5. 245 divided by 5, I think is 49. And 49, I think that's a perfect square, right, is 7 times 7. So I think these are all prime. So we have 5, 7, and 7. So 7 times 7 pair up to make 49, which is a perfect square. And then this 5 is extra. So 49 times 5 is 245. But the square root of 245 is equal to the square root of 5 times the square root of 49. Root 49 is just 7, so we have 7 times root 5 equals the square root of 245. Or this is just simplified down to 7 root 5 is equal to the square root of 245. So the most simplified version here is going to be 7 root 5. Checking this on a calculator, right, the square root of 245, that's going to be about, let's see, 245, take the square root, use a calculator, it's about 15.65. And then take this 7 root 5, 7 times the square root of 5, and that is about same thing, 15.65. So again, feel free to check that, but these are indeed the same thing. For number 8, we have the square root of 112. So let's go ahead and write that down. Square root of 112. That's going to be the square root of it. Let's see what this is equal to. So let's see, what does 112 have hidden inside of it? Well, I know we can divide this by 2 because that's going to be 2 times 56. 56 is the same thing as 7 times 8. 7's prime, 8 can still go to 2 times 4, and 4 can break into 2 times 2. So let's see, we have a 2, we have a 7, we have a 2, we have a 2, and we have a 2. Now 2 of these 2's are going to go ahead and make 4. It's a perfect square. Another pair of 2's are going to make another 4. It's a perfect square. And then we have a leftover 7. So 4 times 4 times 7 equals 112. Right? So if we go ahead and take the square root of 112, that's equal to the square root of 7 times the square root of 4 times the square root of 4. So that's going to be 2 times 2 times root 7 equals root 112. And then 2 times 2 together, that's going to be 4. So that's going to be 4 times the square root of 7 is equal to root 112. Okay, so the square root of 112 is equivalent or the same thing as 4 times the square root of 7. So let's go ahead and check this to make sure we've done this correctly. So let's take this 112, put that on a calculator. So the square root of 112, that's going to be about 10.58. And if we do the 4 times the square root of 7 for root 7, you can see that that is also the same thing, about 10.58. All right, so this also checks out. For number 9, we have the number 275. Let's go ahead and find out the square root of that. So let's go 275. Let's take the square root of it. Okay, so let's say we have 275 and we've got to break it down. So I know we can divide this by 5 because it ends in 5. So 275 divided by 5, that's equal to 55. Okay, now 55 can break into 5 times 11. Oh, so this is not too bad, right? So we have 5, 11, and 5. That's it. Those are prime numbers. So 5 and 5 combine to make 25. That's a perfect square. This 11 is extra. So 25 times 11 is equal to 275. So what's the square root of 275? Well, it's the same thing as the square root of 11 times the square root of 25. The square root of 25 is 5, so it's 5 times root 11. That's equal to the square root of 275. So we're going to go ahead and write 5 root 11. Now if you want to go ahead and check this, let's take this square root of 275, throw that into a calculator and see what that's equal to. 275, the square root of that's about 16.58. And then what's 5 times the square root of 11, or 5 root 11? That's also about 16.58. All right, so again, it's good to just double check to make sure we are understanding getting these correct, and then we can move on. For number 10, we have the square root of 288. Let's go ahead and write that down. We have 288. Let's take the square root of this thing. Let's take this 288 and then break this down into some smaller numbers here to see what factors we can come up with. So maybe 2 times 144. And this 144 might look already familiar, which is great. I'm going to do 2 and 72. Because technically you could stop. 72 is going to be, let's do 2 times 36. 36, maybe let's do 4 times 9. And 4 will break into 2 times 2. And 9 can break into 3 times 3. So lots of prime factors here. So 2 and 2, 2 and 2, 2 and 3, and a 3. Okay, so let's see what they have in common. Let's see, 2 2's pair together to make a 4. Cool. And then we have another pair of 2 2's to make 4. Alrighty. Another pair of 2 2's to make 9. We have this leftover 2 up here. So 4 times 4 times 9 times 2 equals 288. So that means the square root of 288 is the same thing as the square root of 2 times the square root of 9 times the square root of 4 times the square root of 4. Root 4 is 2. Root 4 is 2. Root 9 is 3. Then we have this root 2 here. And that's going to equal this square root of 288. Now 2 times 2 times 3 is equal to 12. So we can go ahead and say that this is going to be 12 root 2, which is equal to the square root of 288. So we're going to go with 12 root 2 here. Now the reason why I said earlier you could probably stop right at the beginning here is just because you might notice that 144 is a perfect square, and you don't have to do the rest of this in the future if you already see that. Okay, so feel free to do that if you want to. The square root of 288 on a calculator here. Let's see, 288 square root. I'm getting about 16.97. And then if you want to try 12 times square root of 2, double check that. I'm also getting about 16.97. So these do match each other. So we know the most simplified radical, 12 root 2, is the same thing as the square root of 288. For number 11, we have the square root of 512. Okay, this is pretty big. Let's take this 512. Let's go ahead and take the square root of it. Okay, again, there's an invisible 2 here. Let's go ahead and see if we can break down this 512 to find some factors that are perfect squares. So 512, we can do 2 times 256. 256 can break into 2 times 128. 128 can break into 2 times 64. 64 can break into 2 times 32. 32 can break into 2 times 16. 16 can break into 2 times 8. 8 can break into 2 times 4. And 4 can break into 2 times 2. So that is a big tree for 512. We have 2, 2, 2, 2, another 2, another 2, another 2, another 2, and then one more 2 down here. Okay, so a 2 and a 2 pair together to make 4. I'm gonna go ahead and write it right over here. Another pair of 2 2s make another 4, another perfect square. Another pair of 2s make another perfect square. Another pair of 2s make another perfect square. And then we have this one extra 2 at the end. So all these together equals 512. If you multiply them, the square root of 512, that's gonna be the same thing as square root of 2 times the square root of 4 times the square root of 4 times the square root of 4 times the square root of 4. Square root of 4 is 2. This is also 2. This is also 2. Also 2. And this is root 2 equals root 512. Now 2 times 2 times 2 times 2 is 16. So we can say that 16 root 2 is the same thing as the square root of 512. Okay, so we can go ahead and say that the square root of 512 is equivalent or the same thing as 16 root 2. Now we can check this, of course. The square root of 512 we can throw into a calculator. So 512, if we take the square root of that, getting about 22.63. 22.63. And then if you take 16 times the square root of 2 and also put that on a calculator, you can see that's also going to be 22.63. So we know that these two decimals are the same and the two radical forms are also equivalent to each other, just written one simplified, one not. Finally, one final problem, number 12, we have the square root of 392. Let's go ahead and copy that down, the square root of this thing. Let's go ahead and put a little 2 here to show we're taking the square root of it. Okay, again, that's implied, but I just want to make sure you know there's a 2 that's there. And then let's take this 392. Let's go ahead and break this down. So 2 times, what's 392 divided by 2? I think that's going to be 196. So 196, that's still an even number, right? So we can do 2 times, if I divide that by 2, I think that's 98. 98, I think we can break that down into, I think we can divide it by 2, right? That's gonna be 49. Oh, that's a perfect square. And we can break that into 7 times 7. So just to be super clear, I'm gonna go ahead and write them all out, even though we know that 49 hopefully is a perfect square because it comes from 7 times 7. So let's see, a 2 and a 2 make a perfect square of 4. And then a 7 and a 7 make a perfect square of 49. And then we have this extra 2 here. So 4 times 49 times 2 equals 392, which means that the square root of 392 is equal to the square root of 2 times the square root of 4 times the square root of 49. I said that backwards, sorry. And so that's going to be 2 times 7 times root 2 equals to the square root of 392. And then 2 times 7 here is 14, so we can say that 14 times the square root of 2, or 14 root 2, equals the square root of 392. So we're going to say that this is 14 root 2. All right, now let's go ahead and just double check this. So the square root of 392. All right, just going to go ahead and throw that onto a calculator, 392. Take the square root, that's about 19 point, I think that's 19.80 if you're rounding to the nearest hundredths place. And let's see, 14 root 2. I'm going to go ahead and check that one now. So root 2 times 14. Yeah, I'm getting this about 19.80 because we have to round to the nearest hundredths place. So this also checks out. Okay, so there you have 12 different practice problems. I'm going to go ahead now and just box where my answers are. These are the most simplified radicals for each of these. Okay, so those are for 9 and 12. Here we have 16 root 2. Inside the radical, you have no perfect square factors. 7 doesn't have anything either. For number 7, there's a 5 inside that has no perfect square factors. It's actually prime, right? So is this 2. This 2 can't be broken down anymore. 13 can't be broken down anymore. This 2 can't be broken down anymore. A lot of primes in this case. Doesn't have to be. Let's see. This is also prime on the inside. Again, as long as it has no perfect square factors inside, it would stay. So even if the number was like 10 on the inside, you would leave that alone as well. So hopefully you found this video helpful and you feel like you can simplify radicals a little more. As long as there are no perfect squares hidden inside, then you are good to go. So as always, keep up the great work, and I hope to see you in the next one.